Good morning, and welcome to our first ever virtual capstone presentation. These seniors have worked exceptionally hard all year to research their topics in order to produce a sizable written project as well as this presentation. As a reminder, the presenter can't see your comments in the chat in real time, but I can. So at any point during the presentation, you can post questions or comments. At the end of the presentation, I'll ask for questions to be submitted in the chat, and I'll pick some of those out to ask the presenter live. Sophia Schua has the most scientific project in this year's cohort. Born out of what I learned was an attempt to settle a discussion between her and others in her life about the best type of blanket to use on a cold night. The result was a project that clarified some of the existing research, as well as an experiment that provided some interesting results, which she will share with you now. So with that, Sophia, how are you today?
Good and a little bit anxious.
You're going to be great. Are you all set to go?
Yep.
All right. So then without further ado, here is Sophia Schua with her project, The Effects of Material Types on Comforter Performance.
Good morning, everyone. My capstone project is on the effect of material types on comforters' performance. So firstly, I like to talk about why I want to work on comforters. My story with the comforters started from the winter in 2018. At the time when I just switched to a blanket, which is very hard and heavy, it was as if I was sleeping under a carpet. And yet, even though it was very thick, it didn't keep me as warm as I was imagined. Then I was searching for a substitute in the wardrobe, where I found this polyester and wool blend comforters. It is about one half the thickness of the blanket, but it performed even better than the thick blanket. This experience contradicts with my conventional wisdom because I have always thought the thicker the comforter, the better it will be. And when it came to the time for course selection during the end of junior year, I decided to take the chance offered by the capstone course to investigate on this topic that I was interested in. My project is quite different from other capstone that you all watched during these 2 days, as mine capstone is more science oriented. While I still incorporate plenty of secondary resources, which are lab results and findings by others, my capstone dedicates a large proportion on primary resources, which are the results from experiments that I conducted myself. I got most of my secondary information from academic journals. The Science Direct database helps me a lot as its collections have most science-related periodicals and journals. And my advisor also recommends PubMed as it comprises a great number of biomedical literature, which is helpful for me to analyze the body activity and its response to thermal change. And lastly, ResearchGate is my free supplementary sources. And then I want to quickly introduce you to some basic information on betting through a mini matching game. So I have labeled each picture with a letter, and I put 3 betting terms on this slide. So you can either type in the text box or just say to yourself of the picture with a sequence of quilt, comforters, and duvet. Like for example, if you think the picture A is duvet and picture B is quilt or picture C is comforters, you will just say B, C, A. So I just give you 5 seconds. Okay, so the correct answer is C, A, B. For anyone who didn't get 100% on this minigame, or even if you did and want to learn more, here are some more detailed information explaining the main features of each term. So comforters usually don't have a cover, but instead it is used with a top sheet, and compared to quilt, it's often thick with filling, and the comforter itself is usually colorful and come with patterns. Duvet, on the other hand, are usually pale white without top sheet, and its cover would have colors or patterns. And most of the time, actually, we've been using comforters and duvet interchangeably. They are indeed quite similar. And lastly, quilt is comparably thinner than comforters and duvet, and is more solid and comes with patterns and top sheet. So comforters are indeed an essential in our life, especially if we live in an area that can get really cold in winter. The materials can affect the comforter's performance. According to a study on teenagers, comforters can impact the sleep quality, and sleep is important to a number of brain functions. Poor sleep can lead to impairments in cognitive control and increased risk-taking. Some of the negative consequences include poor memory and high risk-taking behavior. So picking a good comforter is quite important. And why focusing on materials then? So when I was debating with a friend of mine on the best comforters we could get, we could never come to an agreement. And she has always insisted that the materials doesn't really matter. And if one layer is not enough, and you should just add another one. Well, obviously it makes some sense, but I still thought her statement lacked some scientific evidence. And then after my initial research, it turned out that she was partly right and partly wrong. So we need to think of comforters as a barrier that prevents the loss of heat. So if we look at the formula on the right, the P stands for power of heat loss. K is a coefficient that's related to the materials, and delta T is the temperature difference. A is the surface area of thermal contact, and D stands for thickness. So in our case with comforters, the temperature difference between the body and the environment usually remains the same, and effective surface area means the area of contact, which in most cases remain constant as well. The most important factors of comforters are thickness and types of materials. Heat loss is proportional to the reciprocal of thickness of the barrier. So therefore, the thicker the comforter, it should result in lower heat loss, meaning it is better at slowing down the heat transfer. So that's the part that my friend is correct. But then the other factor, material, is also plays an important role, but its impact on the comforters is more complex, since unlike thickness, materials themselves are qualitative and they are not any defined number, so it's a little bit harder to figure out a numerical relationship between the materials and the thermal resistance. And then after I decided I want to work on the materials, I went through the most common types of materials in the market. So most of the comforters in the market are made of the following 4 types of materials. There are wool, cotton, polyester, and down. And usually you will see goose down or duck down for the down. And each of them have their own advantages and disadvantages. So there are comforters made with a blend of 2 or more types to balance the weakness and strength. Well, however, due to the limited time and budget, I was only able to mainly test non-blend comforters. And in this project, I decided to test on the thermal resistance and permeability of the comforters to figure out the performance. So while we sleep, our bodies always radiates heat due to the thermal difference between the body and ambient temperature. According to the second law of thermodynamics, heat would always flow from object with higher temperature to low temperature. So without comforters, radiated heat warms air molecules around our body, and the warmed air would fall away due to the convection as its densities reduces. And the thermal gradient is created again, so that will lead to another term of heat transfer. So that's the process that we lose heat during sleep. And comforters help to retain the heat by trapping the warm air through their fluffy structure. So air molecules are kept in small air packets among the thousands gaps between the fibers of the comforters. So a good comforter should have a high thermal resistance. And for the permeability, here is a process of respiration. While we sleep, we breathe, releasing energy and water in forms of water vapor. And vapor should slowly effuse through the comforters. However, if the comforters is not as permeable, water vapor might build up inside the comforters, and especially if you tend to sleep hot, having a comforter can cause you to sweat and overheat in the night. It would feel like you are spending the night in the sauna. Therefore, permeability is another component of the performance of comforters. So I conducted 2 experiments, one for each, on thermal resistance and permeability. And I'm going to talk about my experiment method, hypothesis, and result. Here is a table of all 6 comforters I selected and used in my experiment. They included the 4 most common types I previously talked about. They are 5. The first comforters is made with 50% polyester ceramic fibers and 50% wool, and then 100% wool polyester, Xinjiang cotton, white goose down, and duck down. So the first comforter is a blend, and it is a comforter that inspired me to do this project. So I also included it here, even though it's not 100% materials. And before the experiment, I made the following hypothesis on the thermal resistance of each comforters, ranking from the best in thermal insulation to the worst. And the thermal resistance is measured through rate of temperature change of the testing object. So according to my hypothesis, I think goose down should have the best thermal resistance, following with duck down, wool and polyester blend, polyester, and cotton. So for this experiment, I wanted to simulate the thermal response of human body with different comforters. And in order to reach this, I decided to create an object that consists of same matters of human body. And so I looked at the composition of the body. If we break down it to fundamental components, human bodies is made of 55% of water, 20% of protein, 20% fat, and 5% mineral. So I made a bottle of mixture with multi-mineral supplement, egg protein powder, olive oil, and water with their according proportion. So during my experiment, first I warm the mixture up to 80 degrees Celsius with a pot, and then I have this thermometer inside of the bottle all the time. And then I wrapped the bottle with each comforter and record the temperature change every 5 minutes. And here is my final result. So in this scattergram, the higher the final temperature, the better the thermal resistance the materials have, since high final temperatures means smaller temperature difference and less heat loss. And you might notice that I also have a group named without comforters. It serves as like a control group. So if everything is working properly, any trial with comforters should end up with a higher final temperature than the group without comforters. So it shows that there are no major errors or mistakes since every trials are higher than the group without comforters. So from the top to bottom with the best thermal resistance to the least are goose down, duck down, wool and polyester blend, polyester and cotton. And this trend, this ranking is actually very similar to my hypothesis. And besides, there's one thing I find out after the experiment is that I think I could have gotten better results with a longer time span. And then the second experiment is on permeability. I also made a hypothesis on their permeability of each comforters ranking from the best to worst. You can see on this slide. So I believe I thought goose down and duck down would have the best permeability, followed by cotton, polyester and wool blend, and wool. And the permeability in this experiment is measured through rate of change of relative humidity inside the space covered by the comforters. So I used the relative humidity indicator card to measure the humidity, and at a dry place, all the 6 circles on this card are blue, and the spot would turn pink when it reaches the according humidity, and the arrow would show up. Like the picture in this slide, it shows that the current relative humidity is 30%, and the humidifier is used to manipulate the humidity. And one weakness of using this humidity indicator card is that it can't provide precise measuring of humidity. A lot of time I was mainly estimating, so the systematic error could be large. It would be more ideal if you could have the money or time to get a more high-end device. And during my experiment, I placed this humidifier in an open shoebox because the shoebox has five sides that's closed. And then I turned on the humidifier until it reached 60% humidity, which is the highest humidity my humidity indicator card can get. And then covered the open end with comforters and then let the vapor naturally effuses. During the time, I recorded the humidity inside the box every 5 minutes, as I did for the thermal resistance lab. And this is the final result. So in this scattergram, the higher the lower the final humidity, the better the permeability the materials have, as it allows more vapor to leave the box. So from the bottom to the top, with the best permeability to the least are duck down, which ties with goose down, and followed by cotton, polyester, and wool blend, polyester and wool. So the red text are the one that's different from my hypothesis. And as you might notice, all the trials in this experiment didn't vary a lot because the vapor permeates much slower compared to the heat transfer. And so it is recommended to work on it with a longer time span in your turn. And this is the ranking of the 6 types of materials by thermal insulation ability, from the best to the worst. So they are duck down and goose down ties for the first place, and then comes with wool, polyester and wool blend, polyester and cotton. And this is the ranking of the materials by permeability, and this time it is also duck down, goose down that ties for the first place, cotton and polyester and wool blend and wool. And another factor I think is important. Is the price. And here is the ranking of the materials by its cost. So price is another important factor to take into account when picking a good computers. And one thing I want to emphasize is the price here doesn't represent all computers with the same materials. And brands, sales, and other factors can impact the price. Here I'm only discussing the ones I've used, and the cheapest one is polyester, and then cotton, wool, duck down, goose down, polyester, and wool blend. Here is an overall recommendation after my research and experiments. So if you want the best performance and you don't really worry about the cost, duck down and goose down would be the way to go. They have the undoubtedly the best performance in both thermal resistance and permeability. And if you want the most balanced computers, meaning it has a good performance and a doable price, I would suggest wool, as it have a fairly good thermal insulation ability and permeability, and also its price is not too high. And the most economical one, if the customers are very price sensitive, the cheapest one is the polyester, and its performance is overall fair, and it will be the best choice if you really concerned with the price. And this is the one that you can, if one layer is not enough, and you can just add another one. And that's the end of my presentation. And here I want to thank Dr. Spencer and Mr. DG for helping me throughout this process of creating this capstone project. And thank you for watching.
Thank you, Sophia. Well done. I wanted to, first of all, just ask you, you alluded to this a little bit at the beginning of the presentation, but what exactly drew you to this particular topic?
Yeah, I have discussed it a little bit at the beginning. And also another thing is that after debating with my friend, and I kind of remember that in China, it seems like everyone have this perception that cotton is always the best computers to go. And when I ask others like why you think this way, and they will just kind of they can explain to me why. Like there's no any scientific evidence, but they kind of take it as instinct. Like everyone were taught that cotton is the best, and cotton is the best. And I was kind of suspicious, and also I'm always like curious in finding out all these patterns and the relationship between different stuff. And so I decided to create a more scientific process, and then to persuade them and to show them that cotton is not the best, and it's actually a lot of factors can impact the performance of computers. And I want to kind of also have them to if they don't believe in me, and they can follow my lab methods, and then figure out the ranking. So it's like, after all, it's to persuade my friend who doesn't believe cotton isn't the best computer to go.
All right. We had a question from, let's see, Sarah Pasquale. If you could change one aspect of either of your experiments, what would it be and why?
I think I've also mentioned a little bit in the presentation. I was really thinking of the time span. I hope if I could change one thing, I would really wanted to read redo the experiment, which with a much longer time, especially for the one with permeability, because even though I know like the vapor permeates much slower than the temperature, the heat transfer, but still its difference is still much slower than I was expected it. So the difference is not that big, and some and a lot of some of the concepts they kind of overlap in the end, and the so it's not really um persuadable. Like I just think if I could make it longer, and then I can show the much bigger difference, and then reinforce the validity of the experiment.
Okay. Aiden wants to know what you're going to do with all the comforters now that you're done with the project.
Yeah, so I bought all those from the Bed Bath and Beyond, and I wanted to see if I can return it, or otherwise I would, yeah. So I want to take this chance to ask any Ranney's kid if anyone want to take any of the computers, and you can grab one. If you can drive, you can grab one from my home, especially if you are going to college, because I picked most of my computers with twin XL size, so good for
Okay.
college.
So any graduating seniors can get
Yeah.
a blanket from Sophia on their way out. Mr. Neal wants to know how you kept the thickness constant, and did your permeability setup allow you to see the indicator without disturbing the setup?
Yeah. So the thickness, I kept it. I try to keep it constant, and like if one of the like the wool comforters is a little bit thinner than the other ones, and I measure the thickness of all the comforters, and then for the one that's thinner, I just wrap more layers on it. But you know, it's hard to control because one comforter might be 6 centimeters, and then the other one might be 5, and then they're common. If I want to make them the same, I need to at least make them 30 centimeters thick. But that's definitely too thick, especially for the permeability. The vapor just couldn't get out. So I know it's not like 100%. I wasn't able to make it exactly the same, but I tried to minimize the difference. And then for and then one thing that as Mr. Neil mentioned, so I actually disturb the settings a bit while measuring the permeability. One thing, because the indicator card, so it what if it change if I use it to measure 50% humidity, so you know the 10%, 20%, 30%, and 40% would all turn pink, and that card, in order for it to go back to its normal state, like go back to the very dry, like 0% humidity, it would take hours. But I'm measuring it every 5 minutes, so ended up uh, I ended up opening the computers, take out the indicator card, and then quickly stick another one in there, because I bought a pack of it, so there's plenty of it, and then quickly stuck a new card in there, and then wait for another 5 minutes. During that time, I was looking at the card that I just took out with the humidity of the last 5 minutes. So it is definitely some disturbance to the settings. But that's the best that I could do to for this experiment.
Okay. Estella wanted to know how long the experiments actually took you to complete.
So it actually took so even though 30 minutes doesn't look very long, but it's actually since I have 6, so it ended up being hours of it. And while I didn't do the 2 experiment on the same day. That would be like definitely too long. So I have just taken a whole day for each of them during the break, and also so I don't really remember the exact time, but that would be around like some 4 or 3 hours of it.
Okay.
For
Tarun,
each
oh, sorry.
experiment. Yeah.
Right. Tarun asked, do you think the results of your experiments can influence buyers of comforters to choose Goose Down since it performed the best?
Well, I think like bias.
Well, I guess he was asking, does this, do you think this project would potentially lead buyers to go with Goose Down? Is that what you would suggest based on your results?
Like I think it is. After all my results, I think Dog Down and the Goose Down would definitely be the best one to go. And if the price is not a big problem for you, because they just perform much better than like they single out every other types of materials. And so I would suggest that that would be my overall number 1 suggestions.
Okay. Adam Rada wanted to know if you could describe your ideal comforter, though I think that probably was answered in your last question. But do you have any additional information you'd like to share there?
Yeah. So my ideal one would be because I've actually used plenty of comforters, and I know that I have certain criteria for the weight, and then the thermal resistance, permeability. My ideal comforters would be one that's not very heavy, like but I also don't like very lightweighted comforters either. Like I want one that's kind of medium weight. I would describe it as like fifth 100 gram or something, like
Okay.
a little bit heavier than Goose Down or Duck Down, and then but it has the same thermal insulation as a two, and it have good permeability, so that I don't get overheated during the winter when I was playing my phone in the bed. And then, well, because I'm saying ideally, and it's also cheap, and so cheap and performing good and medium weight.
Okay. Evan wanted to know, are there any other experiments you would have liked to have added to your project if you had more time?
Like I think if I have more time, I might want to get like not one more experiment, but I might want to add more comforters in my experiment, and so that I can try to weigh out the brand, the difference of brand, and all those like uh, the other factors like of the comforters that would affect, besides the materials, that would affect the performance.
Okay. And then let's see, Miss Curry, do you think your results would also apply to clothing, like down jackets versus wool coats?
Um, yeah, like, but for the clothes, I've also since I was looking at the comforters, and it's I'm looking at a lot of research on fabrics, and fibers, and so I've actually jumped into a couple of research on clothes. But for clothes, I think it's more complicated, because while I was talking for the comforters, I was assuming that we were so the best comforters in winter, like for you to keep it for it to keep you warm. But for clothing, it's it has much more nuances that you need to take into consider when picking the clothes. Like if for the summer, like you don't want one that's keeping you warm, but you want one that's like you would weigh the permeability, like the breathability higher than the other types. So like even here, even though here I was like say overall cotton is not the best one, but cotton is a very good materials for clothing, especially during the summer, because it's very good at absorbing the water, absorbing the sweat. So during the summer, it's like you get it is feel it will give you much better experience than the other materials. And also like you don't have clothing, and also the clothing would be the way they made the clothing with the same materials would be different, like be the different from the way they made it with the comforters. So that would be the another thing. So the clothes would be a little bit more complicated, but if you are interested, so I would recommend you do another capstone on the materials, effects of materials type on clothing.
All right, that's a charge to the next couple of classes to extend your
Yes,
research.
yes.
I have two more questions for you. First, from Hannah, what was the most interesting thing you found out while you were experimenting with the different comforters?
So actually the most interesting thing is actually kind of jumped to me at the very beginning, because I have always been taught that cotton is the best and cotton is the best, and I've never really thought about like why, and we've just kind of like I was also talking to a lot of friends of mine, especially my Chinese friend, and all of them seem to have the same perceptions. And so when I started to do my first initial research and then find out actually cotton might not be the best, that was kind of shocking for me. And that's like the most interesting thing that I found out. And I was like kind of talking to my friend nonstop about this, and then trying to explain to them what's the pros and cons of the uh, of cotton counters.
Okay. And Dr. Spencer asked, do you think this research experience has affected your future career plans?
Uh, yeah, I think so. I've always been interested in materials, and actually, right now I'm going to study material science and engineering for college. If there's no major like changes in my life, I think that would be my way to go. Like I know this capstone project overall is not like very it's not like those fancy experiment, or like those one on the journal periodical that I looked. It's fairly rough. I'll admit that, and I wanted to learn more skills, like and learn and try more devices, and learn more about all those materials, and uh, that would be my ideal life for college. So I'm going to look more into materials.
All right. Sophia, congratulations. You finished Capstone very successfully, I might add. And good luck and congratulations.
Thank you.
And for everyone else, thank you for joining us this period. At 10:30, our next presentation will begin. It'll be Olivia Noop's Into the Minds of Psychopaths. I hope you'll be able to join us. Thank you.